Alrighty folks, here we are looking at 5.2, which is all about finding common factors, and that is simply looking for things, factors in fact, that appear in all the terms of a polynomial. Like for example, those two letters there, and let's have a look at more numeric example, like 4x plus 4, and obviously is 4 is a common factor to both. In fact, I can divide both of those terms by 4, and when I do, it looks like this. And then the way to factor something, basically what we're doing is we are undistributing the 4, the common factor. So kind of like the reverse of the distribution principle, we're kind of playing that whole movie in reverse. And so if I take the 4 out front, I'm left with whatever is left over here to go into the bracket. So in other words, x plus 1. So, and again, to double check your work to make sure that you've done it right, you definitely could just do the distributive law, and you should get 4x plus 4, the original thing, back again, which we certainly do. All right, well, let's look at a different example then. Okay, can you see what the greatest common factor is for these two terms here? I'll give you a few seconds here to think about it. All right, well, if you said 5, then you are partially correct, because in fact it is 5x. 5x can be divided out of both of those, and when you do that, 15x squared divided by 5x leaves you with 3x, and then minus 5x times 2. Okay, and so then I can pull the 5x, and I see that I have no other common factors remaining when I do that, and there is my factored binomial. Okay, and again, if you wanted to, you could do the reverse and do the distributive principle, and you get the same thing back, 15x squared minus 10x. Okay, let's try a slightly more challenging one then, okay? Okay, so I'm going to give you a few seconds, just pause the video here, and I'd like you to, as best you can, write out the factored form of this expression, and we'll compare answers shortly. And shortly has come about right now. Here is the common factor. That is 4ab. 4 is a common factor of 24, 16, and 4. And there's an a in every term and a b in every term. And that's all that's common. So then the remainder, what gets put in the brackets, if you divide everything by 4ab, let's look what that looks like for the first term only. So in your head, so to speak, or you could write it down if you needed to, you're doing this equation. 24 divided by 4 is 6. A squared divided by a, well, that's going to be a to the power of 1, so just a. B divided by b is, if you said 0, smack yourself in the face a little bit. It's not 0, it's just 1. And so that's going to be the number that goes here in my bracket, 6a. That's just for the first term. I do the same thing for the other ones, and this is what I get. Okay, and that is my final answer. Okay, now the really important thing to note here is that the 4ab has to be divisible out of all three of those terms. Okay, so if I change the question a little bit and make that last term a negative 3ab squared, okay, well 3 is a common factor for 24 and 3, but it does not go into 16. So the only common factor I have here then would be AB. Okay, and then that's what I would pull out front. All right, so even if you really want to, you can't do it. Okay, so don't try. Okay, well, I know what you're thinking. Boy, this is pretty easy. That's right, it has been. And now for the hard stuff. Check this one out. Okay, 4 terms here, and maybe you're looking at it going, this is actually pretty easy, BB, because there are no common factors to all 4 of those. And to that I say you are correct. There are not any common factors to those all 4 terms there. However, watch what I can do, and believe it or not, this will come in handy later on this chapter. I'm going to draw an imaginary box around, okay, well, it's not so imaginary, but in your mind, you're going to draw an imaginary box around the first two terms because there are some common factors. There's a common factor for the first two terms, that much we can see, and so I could rewrite the first two terms as a factored binomial. In other words, it'd look like this. And you say, okay, that's great, BB, but what about the rest of it? Well, the rest of it can just be added on there if I wanted to. Okay, but the difference though is that the second two terms also have a common factor. So guess what that means? That's right, another imaginary box. So, can you see what the greatest common factor is here? Why don't you go ahead and write down what you think, or say what you think the answer is for the last half of this factored quadrinomial. And if you said that, you're right. So there you go. Okay, so we don't have to factor necessarily. We don't have to factor out everything. We can sometimes only factor out a portion of it. And it is still going to be helpful in some cases. It's not helpful here, which is why we typically don't do it. Okay, so that last example that I had up there where I could have factored out something from two of them, I could have, but it wouldn't have been very helpful. Like this one here is not very helpful. But let me show you one where it is helpful. Okay, well, hopefully I copied this down correctly. So here again we see there are no like terms here, so I can't factor this out with one common factor, but what you don't realize is you can factor this out still as a multiplication. So let's do the same thing. Draw an imaginary box around the first two terms, pull out the common factor, and we'll compare answers in 3 seconds. Okay, so hopefully you saw that 5m was the common factor between 10m squared and negative 25m, leaving us with 2m minus 5. Okay, well, let's have a look at the second set of numbers as well then, and see if you can come up with what is common there and factor it out and what's left over. Alright, so hopefully you see that the 2n is what's common to both there. And what does that leave you with, you might say? Well, hopefully you saw that the answer was also 2m minus 5. So you're probably recognizing then that those 2m minus 5s are common factors as well. Okay, it's 5m times 2m minus 5 plus 2n times 2m minus 5. Still not convinced? Well, let's say I wrote this down. 5my plus 2ny, and asked you to factor it, you would say, okay, well that would be y times 5m plus 2n, right? Correctly so, because y is a common factor to both. But what if I all of a sudden told you at the very end that y was equal to 2m minus 5? In which case, that would make this 2m minus 5 times 5m plus 2n, right? It's the same thing. We can do the same thing with that one up top there that we started. In other words, pull out the 2m minus 5 that's common to both. Then leaving behind whatever is not there, which would be the 5m and the 2n. That's what's left over. And so that's what I go ahead and write inside my brackets then. 5m plus 2n, and there you go. Okay, but it's really important you put this in brackets as well, because that's the factor that you pulled out. And so there I've written that giant quadrinomial as a product of two binomials. Okay, and if you were to do the expansion, the distribution law, you would get the same thing that we started with. Yes, it's in a different order, but all the terms are still there. Okay, so there you go. That's how we do factoring of really big polynomials that you'll never have to do after today. Let me just show you. There you go there. Okay, now I'm also going to give you a little hint here. You may be recognizing that the 6xy and the negative 4t have common factors, but so do the negative 4t and the positive 12xt. Well, just so you know, the order here won't matter. In other words, you could write it out that way, all the same terms, just in a different order. Notice the signs are the same in front of every term, and you can factor those. Factor the first two, like factoring by pairs, like we've been doing, and you'll get the same answer. Okay? So if you can get the first one, great, and if you feel like giving yourself a little bit of an extra challenge, try the other one. It's not going to be more challenging, it's just going to take a bit more time, just because you have to do 2 questions instead of 1, but just prove to yourself that they're going to be the same thing, and we will go over this one tomorrow in class. All right, folks, see you then.